All right, let's get into it. You see these things on construction sites all the time, right? But I bet you've never really thought about the insane engineering gauntlet a modern hybrid cement mixer has to survive before it ever pours a single drop of concrete. Today, we are pulling back the curtain on its ultimate engineering exam. So here's our roadmap. We're going to start with the big, high-stakes problem these trucks have to solve. Then we'll dive into the core philosophy behind how you test something this complex. We'll see how engineers literally test a digital ghost of the truck. Then watch them physically torture the components and follow the real thing onto the test track for its final trial. And finally, we'll understand the whole point of all this work, getting to what they call engineered certainty. You have to understand, this is not just any old truck. We're talking about a complex 400-volt hybrid beast that works in some of the most brutal environments you can imagine. And with all that new tech comes a totally unique and absolutely catastrophic risk of failure. This phrase right here says it all. It basically means if the drum stops, the truck is scrap. That is the single biggest nightmare for this machine. Think about it. If the hybrid electric system fails and that huge drum full of wet concrete stops spinning, well, that concrete starts to harden. The whole thing turns into one giant, multi-ton, immovable block of scrap metal, a ridiculously expensive disaster. So the big question is, how do you stop that from ever happening? Well, the answer is a really powerful engineering philosophy that's all about finding and killing every single potential failure, long before the truck is even a real thing. And this is that philosophy. Fail early, fail cheap. It's so simple, but so brilliant. You know, finding a software bug in a computer simulation, that costs pennies to fix. Finding that exact same bug after the truck has built and is now a giant concrete popsicle, that costs a fortune. The entire testing strategy is built around this one powerful idea. And that strategy is called the test pyramid. It's what engineers call a shift-left approach. Think about it. The huge, wide base of the pyramid, the foundation, is all done in the virtual world. The vast majority of testing happens on computers before a single piece of metal is ever cut. The real vehicle testing, that's the tiny little point at the very top. It's not there to find problems, it's there to confirm that they've all been solved. And check this out, this slide really breaks down what that means in practice. You can see the different levels, right? Model in the loop, software in the loop, and so on. But look at those coverage goals. They test over 90% of the control logic and 95% of the software code before it ever touches a real piece of hardware. It's amazing. By the time you get to the really expensive physical tests, you're just confirming everything works together. So let's talk about that foundation of the pyramid. Before this truck exists in the real world, it lives as a digital twin. It's this incredibly detailed computer model, a digital ghost, really, that can be pushed to its absolute limits 24/7 without ever scraping a single piece of metal. And this virtual testing happens in 3 key stages. First up is model in the loop, or MIL. That's all about the big picture strategy. Like, if the battery gets low, does the system know to prioritize spinning the drum over everything else? Next is software in the loop, SIL. This is where they take the actual production code and throw thousands of virtual curveballs at it. And finally, you have hardware in the loop, HIL, where they plug the real-life electronic controllers into the simulation to see how they physically react to a crisis. Okay, so the code is solid. The brain has been proven in the virtual world. Now, it's time for the physical hardware to prove it can take a punch. This is where the individual components get sent to the lab to be systematically and brutally tortured. Let's start with the heart of the hybrid system, the 400-volt high-voltage battery pack. Now, for a construction vehicle like this, just holding a lot of energy isn't enough. It has to be tough as nails. It has to survive a battlefield, basically, day in and day out. To simulate an entire lifetime of being bounced around an off-road construction site, they strap the battery to what's called a shake table, and it gets subjected to vibrations that generate over 8.5 Gs of force. That's more force than a fighter pilot pulling a high-speed turn. And it has to endure that non-stop for a full 24 hours. And it gets crazier. They take key components and put them through thermal shock. They are literally flash frozen to an Arctic minus 40 degrees Celsius and then, seconds later, baked to a blistering 85 degrees Celsius. And they do that over and over and over again, 100 times, to find any possible weakness. And being waterproof, that's not nearly good enough. On construction sites, they clean everything with high-pressure steam jets.
So all the high-voltage parts have to meet something called the IP69K standard. That means they can survive a point-blank blast from what is essentially a scalding hot, high-pressure fire hose, without a single drop of water getting inside.
Now we come to the electric motor's ultimate exam. It's called the Menn-Dwan test, which kind of translates to a stalled drum. This simulates that absolute nightmare scenario we talked about, trying to restart a drum full of concrete that's already started to harden. This takes 3 to 5 times the normal torque. The motor has to deliver that massive surge of power without breaking a sweat.
So, with all the individual parts proven tough, it's finally time to put them all together. The very first complete trucks are built. But they aren't going to a customer, no way. They are heading straight to a special proving ground for their final, most brutal exams. Proving grounds are basically torture tracks for vehicles. They use these special surfaces to pack an entire 300,000-kilometer lifetime of abuse into just a few weeks of driving. Look at this. Driving just 1 kilometer on those horrible Belgian blocks is like putting 40 kilometers of wear and tear on the truck on a normal road. It's just insane. Next, the truck has to prove it can work anywhere on Earth. So they take it to the hottest, coldest, and highest places they can find. Out to the desert to run at full load in 45-degree heat, up to the Arctic for cold starts at -30, and way up onto mountain plateaus over 3,000 meters high to make sure it doesn't lose its breath in the thin air. But this might be the most critical test of all. It's called fault injection, and it's governed by a super strict safety standard, ISO 2662. This is where engineers get to break the truck, on purpose, while it's running. They'll disconnect sensors, cut communication wires. They simulate every failure they can think of to make absolutely sure the safety systems kick in exactly as planned every single time. It's all about guaranteeing a predictable, safe reaction when things go wrong. So after all of that, after the digital simulations, the component torture, the real-world abuse, what's the whole point? What's the payoff for this incredible investment of time, money, and engineering talent? This quote from the engineering director really just nails it. Testing isn't seen as a cost. It's an investment. It is the only way you can actually buy certainty. Certainty that the vehicle is safe, that it's reliable, and that it's going to do its job before you ever sell a single one. So you see, it's not like the truck just gets a passing grade. Before it can be signed off for mass production, it has to meet this incredibly strict 5-point definition of done. Every single one of these gates has to be passed, from the virtual world to the real world, with absolutely no compromises. This whole process, which engineers call the DVP&R, or Design Verification Plan and Report, it isn't about checking boxes. It's about building this huge body of evidence that proves the design is solid. The final result isn't a report card. It's a guarantee. A guarantee to the company, sure, but most importantly, a guarantee to the person who's going to be sitting in that cab, relying on this machine to do their job safely every single day. It's just a staggering amount of unseen effort, isn't it? So the next time you drive past a construction site and see a piece of heavy machinery at work, you'll know about the secret gauntlet it had to survive to get there. It really makes you wonder, what other complex things we rely on every day have passed their own invisible engineering exam?